Today, we're going to look at one more type of factoring, which is called factoring a difference of squares. Just to summarize what we've been doing over the past probably 2 weeks, we've been factoring trinomials where they're always in the form x squared plus or minus b times x plus or minus c. And these signs changed all the time. We always had a 1x squared or whatever the variable was at the beginning, which is why when you wrote the factors, it was always an x times an x or an a times an a and so on. So we always started with the x's at the beginning of each of the factors. Just to kind of summarize, if the c is positive, we know that we always multiply to c, right? We multiply to c and add to b. So if we're going to multiply to a positive c, the signs always have to be the same. We always had positive times positive or negative times negative. And what ended up happening was that the signs were whatever the sign of b was. So if I was going to add up to a positive b, I did a plus plus a plus. If I was going to add to a negative b, I would have a minus and a minus. If the c was negative, if we're going to multiply to a negative, I need a positive times a negative, so the signs were different. And then the bigger number got the sign of b. When we add things with opposite signs, we take the difference and give it the sign of the larger number. It's kind of a shortcut way of looking at what we've been doing with the factoring the last couple of weeks. So what we've been doing is saying if I have x squared plus 9x plus 20, the numbers multiply the constant and add to the coefficient of x. And I look at the factors of 20, and hopefully as you do more of these, you don't have to list off every single pair every time. I find the pair that adds up to 9. If they're multiplying to a positive, I just think what adds to 9. If I want to add to positive 9, it has to be x plus 4 and x plus 5. Here, I want to multiply to a negative 44 and add up to negative 7. So when I'm multiplying to a negative, I again think of the factors of 44, but realize that in order to get a negative, one of them has to be positive and one negative. So when I'm looking for the numbers to add to negative 7, I'm thinking the difference between them will be 7. 4 and 11 are 7 apart. If I want to add up to negative 7, I have to have positive 4 and negative 11. The larger number has the same sign as b. So my factored form is x plus 4 and x minus 11. X squared minus 16x plus 60. Multiply to 60, add to negative 16. 60 has a bunch of factors, 1 times 60, 2 times 30, 3 times 20, 4 times 15, 6 times 10, and I'm looking for the pair here that has they add to negative 16. 6 and 10 add to 16, negative 6 and negative 10 add to negative 16. X minus 6, x minus 10. My last example, I multiply to negative 5 and add to positive 5. I'm multiplying to a negative. My factors of 50 are 1 times 50, 2 times 25, and 5 times 10. I want the numbers where 1 is positive and 1 is negative to add up to 5. So I want the difference between these numbers to be 5. In order to get positive 5, I have to take 10 minus 5. The bigger number has the same sign as that coefficient of x, positive 10, positive 5. So my factored form is x minus 5, x plus 10. What's new today is we're going to factor what's called the difference of squares. Difference means subtraction, and squares means to the second power. So a difference of squares is a quadratic binomial, 2 terms, in the form x squared minus a squared. Here are some examples. X squared minus 25, because that's x squared minus 5 squared. X squared minus 81, which is x squared minus 9 squared. X squared minus 100, which is x squared minus 10 squared. I always have a perfect square in each of the terms, and they're always subtracted. We can factor a difference of squares the same way we factor our trinomials. When we do this, we rewrite the middle term. There is no middle term, so there is 0x. And then we can factor the trinomial like we have been. So if I have x squared minus 25, That's x squared plus 0x minus 25. I need to put this placeholder in here because my numbers are going to multiply to negative 25 and add up to 0. Now, if we want two numbers to add to 0, that means they're going to cancel out with each other. So I want the factors of negative 25 that will cancel out with each other. If I have a negative 5 and a positive 5, they will cancel out. I have x plus 5 and x minus 5. And there's a pattern when factoring these difference of squares. It's always x plus a number and x minus the same number because they always add to 0. Couple more examples. X squared minus 81 is x squared plus 0x minus 81. I'm going to multiply to negative 81 and add to 0. I need numbers that multiply to 81 that are exact opposites of each other, so they add up to nothing. 81 is 9 squared. It's 9 times negative 9. X plus 9, x minus 9. X squared minus 100. X squared plus 0x minus 100. I'm multiplying to 100 and adding to 0. My factored form, I need numbers that multiply to 100 and cancel out with each other. They have to be exact opposites. So it's 10 times negative 10. X plus 10, x minus 10. Notice the pattern. X squared minus 1. X squared plus 0x minus 1. I multiply to negative 1 and add to 0. What numbers multiply to 1? 1 times 1. How do I get them to add to 0? 1 times negative 1. X plus 1, x minus 1. And lastly, x squared plus 0x minus 16. I'm going to multiply to negative 16 and add to 0. I need numbers that have the same absolute value. They're going to have opposite signs so they cancel out and give me 0. 16 is 4 times 4. So to get negative 16, I need 4 times negative 4. X plus 4, x minus 4. For today's worksheet, you are going to have trinomials mixed with difference of squares. So you need to remember what you've been doing over the past week or two along with this new step for difference of squares.